Recall that when we factored a trinomial, we factored a type of trinomial such as x squared plus bx plus c. For example, we factored such as x squared plus 9x plus 20. When you factor this trinomial, you open parentheses, here x, and you find those whose multiplication is 20, and when they are added they are 9. Okay, what are they? They are plus 5 and plus 4. If you multiply plus 5 into plus 4, you will get 20. If you add them, you will get 9. Let's check the outer here. X multiplied in 4 is 4x, and the inner 5 multiplied in x is 5x. When you add them together, you will get 9x, which is the middle term. Then your answer or your factoring is correct. Also, we factored trinomials such as ax squared plus bx plus c. For example, 9x squared plus 10x plus 1. Let's factor this. If we say, for example, 3x here and 3x here, when you multiply them together, you will get 9x squared. Okay, so we factored them. What are the numbers if you multiply? Now will give you plus 1, and if you add, you will get 10. So what are they? Let's take the 1 here first. It could be a multiplication of plus 1 and plus 1. Now take the outer. 3x multiplied in 1 is 3x, and take the inner. 3x multiplied in 1 is 3x. When you add them together, you will get 6x, which is not the middle term. Okay, so we will exclude this type of factoring. Now let's check with 9x here and x here, and check if here plus 1 and here plus 1. Let's take the outer. 9x multiplied in 1 is 9x, and 1 multiplied in x is x. If you add them together, you will get 10x, which is the middle term. Then your factoring is correct. If we take another example, let's take another example. If we say 8x squared plus 10xy minus 25y squared. How do we factor this? If you factor this, this is equal to, here you put 4x, and here you put 2x. Okay, now you check numbers that when you multiply, you will get minus 25y squared, and if you add, you will get 10xy. So what are those numbers that if you multiply, you will get 25y squared? You may say y and minus 25y, or minus y and plus 25y, or you can say 5y and minus 5y, and here you say minus 5y and 5y. Those are the numbers you may check. Also for the 8x squared, you may check with 8x and x, and you may check with 2x and 4x, and see what is the correct answer of that. If you multiply the numbers here together, you will get minus 25y squared, and if you add them, you will get the middle term, which is 10xy. Eventually you will find the answer to be using the trial method. Of course, we want this number to be as positive as it could be, so we will put here plus 5y, and here we will put minus 5y. y. If you multiply these numbers together, you will get minus 25y squared. And let's check the outer now. 4x multiplied in 5y is 20xy, and if you multiply minus 5y into 2x, you will get minus 10xy. If you add them together, you will get 10xy, which is the middle term, then your factoring is correct. We saw also the third case when it is impossible to factor, or in other words, non-factorable over integers. For example, if you remember x squared plus 3x plus 7, we found this as non-factorable over integers. Okay, the question which is important to us, how to determine whether it is a factorable or non-factorable. How to determine whether if it is factorable or non-factorable. We know this was a factorable trinomial because we factored it. Also this one is a factorable because we factored it, and this one is a factorable trinomial because we factored it. However, this trinomial is non-factorable over integers. How to determine that it is non-factorable over integers? Because sometimes you may think that it is non-factorable and you say non-factorable over integers. However, you may miss something, and the trinomial itself can be factored. Therefore, it is important to know whether the trinomial is a factorable trinomial or non-factorable trinomial. How is that? Before answering this question, we need to know important things. We need to know what are perfect squares. A perfect square is a product of a term and itself. For example, if you have a term which is 7, the product of this term and itself is 7 multiplied in 7. Okay. What does this equal to? It is equal to 49. This is called the perfect square. If we say y, the product of the term y and itself is y multiplied in y, then the perfect square is y squared. If we say a term 2x cubed, the product of 2x cubed and itself is 4x to the power 6. This is a perfect square, and this is a perfect square, and this is a perfect square. If we say x to the power n, the product of this term into itself is x to the power n multiplied in x to the power n. The perfect square is x to the power 2n. Now, if you take the square root of a perfect square, you will get exactly the same term. If you take the square root of a perfect square, you will get exactly the term. So let's see, the square root of 49 is square root of 49 equals 7. Square root of y square is the square root of y square equals to the absolute value of y. square root of 4x to the power 6 is equal to 2 the absolute value of x to the power 3. Square root of x to the power 2n is equal to the absolute value of x to the power n. Also, we have perfect cubes. What are perfect cubes? The product of the same three terms is called a perfect cube. For example, if we have a term, let's say 5, if you multiply in itself 3 times 5 multiplied in 5 multiplied in 5, the product is 125. The product of a term in itself 3 times is called perfect cube. If we take another example, let's say we have z. If you multiply in itself 3 times z multiplied in z multiplied in z, the product of this is z cube. This is a perfect cube. Z cube is a perfect cube. 125 is a perfect cube. Another example, if we say 3x squared, if you multiply 3x squared into itself 3 times, you will have 27x to the power 6. This is about a perfect cube. Another example, if we take, for example, x to the power n. If you multiply x to the power n itself 3 times, the product is x to the power 3n, which is the perfect cube. This is a perfect cube. This is a perfect cube. This is a perfect cube. Now, if you take the cube root of a perfect cube, you will get exactly the term. Let's say if we take the cubic root of 125, this is equal to 5. The cubic root of z cube is z. The cubic root of 27x to the power 6 is 3x squared. The cubic root of x to the power 3n is x to the power n. Keep the perfect squares and perfect cubes in your mind because they are important. The perfect square will guide us on how to decide whether a trinomial is factorable or non-factorable over integers. We will see. If you remember how to determine a factorable or non-factorable of a trinomial when factoring, now we can answer this question. To answer this question, a theorem known as the Factorization Theorem is deciding whether a trinomial can be factored or cannot be factored. The Factorization Theorem. The Factorization Theorem says ax squared plus bx plus c can be factored if and only if b squared minus 4ac is a perfect square. This is the factorization theorem. It says this trinomial ax squared plus bx plus c can be factored if and only if b squared minus 4ac is a perfect square. This is simply the factorization theorem. So whenever you have a trinomial, if b squared minus 4ac is a perfect square, then the trinomial can be factored. If b squared minus 4ac is not a perfect square, then the trinomial cannot be factored. For example, if we say determine whether each trinomial is factorable over the integers, we have a 4x squared plus 8x minus 7. How to answer this question? We need to find whether b squared minus 4ac is a perfect square. Okay, here this is in the form of ax squared plus bx plus c, right? A is what? Is 4. B is what? Is 8. C is what? Is minus 7. Now check whether b squared minus 4ac is a perfect square or not. Let's see. B squared minus 4ac equals to what? 8 squared minus 4 multiplied in a, which is 4, multiplied in c, which is minus 7. This is equal to 64 minus 16 multiplied in minus 7 is plus 112. This is eventually equal to 176. 176, is it a perfect square or not? 176 is not a perfect square. 176 is not a perfect square. What do you get now? This implies that 4x squared plus 8x minus 7 is non-factorable over integers. Let's take another example. 6x squared minus 5x minus 4. Is this trinomial factorable or not? We want to check whether b squared minus 4ac is a perfect square or not. So this is in the form of ax squared plus bx plus c. How you get? A is 6, b is minus 5, c is minus 4. So b squared minus 4ac is equal to what? Minus 5 squared minus 4 multiplied in a, which is 6, multiplied in c, which is minus 4. So this is equal to 25. Negative multiplied in negative will give a positive number. So positive 4 multiplied in 6 is 24. 24 multiplied in 4 is what? 96. So this is equal to 121. 121 is a perfect square. 121, it is a perfect square. Why is that? Because if you multiply 11 multiplied in 11, this is equal to 121, which is a perfect square. The square root of 121 is 11. Okay? This implies what? This implies 6x squared minus 5x minus 4 is factorable over integers. then you are done. You solve the question. If you are interested to factor this, let's see. We will put here 3x, I will factor, and here I will put 2x. Okay, and if you say here minus 4 multiplied in plus 1, if you check the outer, here it is 3x, the inner is minus 8x. If you add them together, you will get the middle term, which is minus 5x. Then your factoring is correct. This is additional to the question, because the question asks determine if it is factorable or not. You determine this trinomial is factorable over integers, and so far you are done. Let's take another example. 16x squared plus 8x minus 35. We want to check whether this trinomial is factorable or not over integers. Of course, we would like to use the factorization theorem. B squared minus 4ac should be a perfect square. So this is in the form of ax squared plus bx plus c. A is what? A is 16. B is what? B is 8. C is what? Is minus 35. So b squared minus 4ac equals to what? 8 squared minus 4 multiplied in a, which is 16, multiplied in c, which is minus 35. Of course, this negative multiplying this negative will be a positive number. If you do the multiplication, you will find the answer to be 2304. Is it a perfect square or not? This is a very huge number, especially you don't have a calculator. How to check? I will give you a hint how to check whether this is a perfect square or not. However, for this example, 2304 is a perfect square, because 48 multiplied in 48 equals 2304. So this is a perfect square. This implies that 16x squared plus 8x minus 35 is factorable over integers. Okay, before going to question D, let me give you a note. If you remember in the previous example, 2304, how to determine its term or whether it is a perfect square or not. We said it is 48 multiplied in 48. Yes, so how do we determine if we have a big number and you don't have a calculator? You start by seeing the first digit here. What is the first digit? It is 4. So what is the term that if you multiply by itself, it will give you a perfect square starting by 4? We know that 8 multiplied in 8 is equal to 64. So this 4 may be a reason to be this 4. So we will start by multiplying 8 multiplying 8. Then I will do 18 multiplying 18 and check. And 28 multiplied in 28 and check. And 38 multiplied in 38 and check. And 48 multiplied in 48 and check. Once you finish, you will find that the answer is 2304. What if this number was 2200 and let's say 94? It is not a perfect square. After answering all these, 18 multiplied 18 is 324, and 28 multiplied in 28 is 784, and 38 multiplied in 38 is 1000 444. So if the final number is 2294, it should be between here. Okay, so once you jump here to this number, which is 2304, this means 2294 is not a perfect square, is not a perfect square. Let me give you another example to be more clear about this. If a question comes to you, is this a perfect square or not? We know that this 9 can come from 3 multiplied in 3. Okay, so you add right now. 3 multiplied in 3 is 9, right? And 13 multiplied in 13 is 169. And 23 multiplied in 23 is 529. And 33 multiplied in 33 is 1089. And 43 multiplied in 43 is 1849. And 53 multiplied in 53 is 2809. And 63 multiplied in 63 is 3969. It is smaller than this number. We should go more. Now 73 multiplied in 73 is 5329. So now focus. This number is greater than this number, and we didn't get a perfect square of 4409. This means this is not a perfect square. I hope this example is clear. Now going back to our question, to use the factorization theorem to determine whether each trinomial is factorable or not over the integers, we have question now D. 8x squared minus plus 26x plus 15, is it factorable over integers or not? We will check whether b squared minus 4ac is a perfect square or not. Here this is in the form of ax squared plus bx plus c. So a is 8, b is 26, c is 15. Now checking whether b squared minus 4ac is a perfect square or not. This is equal to 26 squared minus 4 multiplied in a, which is 8, multiplied in c, which is 15. This is equal to 196. 196 is a perfect square. If you multiply 14 into 14, you will get 196. This is a perfect square. So b squared minus 4ac here in this question is a perfect square. This implies that 8x squared plus 26x plus 15 is factorable over integers. Now we solve the question. If you have enough time to practice and you are interested to factor this, the factorization of this is 4x plus 3 multiplied in 2x plus 5. If you see the outer, here we have 20x and here we have 6x. If you add them together, you will get 26x, which is the middle term. Then your factorization is correct. Noting that we have factored 8x squared into 4x and 2x. Question E, 4x squared minus 5x plus 6. We want to check if this trinomial is factorable over integers or not using the factorization theorem. We would like to check whether b squared minus 4ac is a perfect square. So the solution, this is a here is 4, b here is minus 5, c here is 6. Therefore, b squared minus 4ac equals 2 minus 5 squared plus minus 4 multiplied in a and c multiplied in 4 multiplied in 6. This is equal to minus 71. This is of course a negative, it couldn't be a perfect square. Therefore 4x squared minus 5x plus 6 is non-factorable over integers. Be careful whenever you have a negative sign. If I say to you the answer may be, instead of minus 71, minus 81, we know that 81 is 9 multiplied in 9. However, here we have a negative sign, so it is not a factorable, also this not factorable over integers, okay, because this is not a perfect square. There is no square root of minus 81 that will give you 9 or minus 9, okay, so this is not also a perfect square. In case if you have an answer minus 81 or any negative number, then b squared minus 4ac is not a perfect square, and therefore it is non-factorable over integers. So be careful about that. Let's now take another question. If I say 6x squared minus 14x plus 5, we would like to check whether b squared minus 4ac is a perfect square or not. So here a is 6, b is minus 14, c is 5. Then b squared minus 4ac is equal to what? Minus 14 squared minus 4 multiplied in a, which is 6, multiplied in c, which is 5. Then this is equal to 76. 76 is not a perfect square. This is not a perfect square. Therefore, this implies that 6x squared minus 14x plus 5 is non-factorable over integers. Do not let your math teacher fool you, okay? If there is a question, let's say 2x squared plus x minus 1. This can be factored as 2x here and x here, okay? Here we have, let's say, plus 1, and here we have minus 1. If you check the outer, we will have 2x. If you check the inner, we will have minus x. Add them together, you will get x, which is the middle term. Also 2x and x, if you multiply together, you will get 2x squared. Then your factorization is correct. Again, do not let your math teacher fool you. Suppose if a question said factor minus 2x squared minus x plus 1, okay? Now this is maybe weird, okay? However, you can do this. This is equal to, take the negative outside, and then now you see what is inside, or let's say the inverse, the additive inverse of this one, okay? Take the additive inverse of this one, we bring the negative outside, okay? And we see, if you take the negative outside, then this should be 2x squared
plus x minus 1. Of course, we know how to factor this one. We already factored here. Okay, it is this one. Okay, so what will be our answer? This will be negative multiplied in 2x minus 1 multiplied in x plus 1. Okay, you can write it in too many ways. You can choose to write this one as, let's say, if you want to multiply here, it is like, this is like minus 1. Okay, how to multiply, for example, minus 1 multiplied in 4 multiplied in 3? You multiply only with one term, not all term. You will not multiply here and here. Of course, this is wrong. You will multiply only in one term. Of course, I may say minus 4. The answer is minus 4 multiplied in 3. Similar, this is similar. If you do it here, the same. Okay, I will do just only in one binomial. I will take this negative inside one binomial. Okay, so this is equal to, I will take it inside this. So this would be 1 positive 1, because negative multiplied in negative would be positive. So it is positive 1 minus 2x, and this will remain the same, x plus 1. Okay, you want to check, use the distributive property now. Multiply this into here and into here, and this one into here, and this one into here. You will find that 1 multiplied in x is x, and 1 multiplied in plus 1 is plus 1, and minus 2x multiplied in x is minus 2x squared, and minus 2x multiplied in 1 is minus 2x. Now you add like terms. We have here like terms, so this will come here. Of course, we will have minus 2x squared, and this two like terms, when added, we will have minus x, because minus 2x minus x is minus x, and we will have plus 1, which is this one. Then your factorization is correct. So do not let your math teacher fool you. You should, if you see something like this here is negative, you may take the negative outside and change the sign inside, as I told you before, for the additive inverse. And then you take this minus 1, multiply it in either this one or this one. But for this time, I chose only this one. Okay, I changed the sign here, and this remained the same. Okay, you can choose to change the sign of x plus 1 and let 2x minus 1 remain the same. Let's see together. If we here start from here, let's say we have minus 1 outside, of course, multiplied in 2x minus 1 multiplied in x plus 1. Now take this inside. I would say this is equal. I will leave 2x minus 1 the same and change the sign of this one. So this is will be minus x minus 1. If you want to check whether your factorization is correct, now check. 2x multiplied in minus x is minus 2x squared, and 2x multiplied in minus 1 is minus 2x, and minus 1 multiplied in minus x is plus x, and minus 1 multiplied in minus 1 is plus 1. So it is minus 2x squared minus x plus 1, which is our original question, the same. Okay, so again, to simplify, we have 2x squared plus x minus 1. This, when it is factored, it is equal to, here we have 2x multiplied here in x, here we have plus 1, and here we have minus 1. Okay, and if we say minus 2x squared minus x plus 1, this is, when it is factored, it is equal to, take the negative outside, then change the sign, 2x squared plus x minus 1. Now you factor, so this is equal to minus 2x minus 1 x plus 1. Okay, if you want to get rid of this negative, okay, if you don't want, it's okay, fine. This is a one way to write the answer. This is a one way. Another way, if we say we want to take the negative, so this negative we will multiply in one binomial from this two product of binomials. I will take now this binomial, so if you take it inside, that should be negative multiplied in minus 1 is positive 1, and the negative multiplied in 2x is minus 2x. This will remain the same, x plus 1. This is a second way. A third way, if you would like to write this one, if you want to get rid of the negative, I would multiply this negative inside x plus 1. So what to do? 2x minus 1 will remain the same, and the negative, when it is multiplied inside x plus 1, this should be minus x minus 1. So this is the third way of writing the final factorization answer. So in case you have a negative, do not be afraid, take the negative outside and open parentheses and put the additive inverse, where you change the sign of all of these terms. Okay, then you factor. I factored it to two binomials, product of two binomials. This negative, I multiplied it first in 2x plus 1. I found this answer. And this negative, I then multiplied in x plus 1, and I found this answer. And that's it.